In this video, I'm going to talk about how to define data-defined variables using Visual Studio. First, I'm going to go to the hard drive C and open my hard drive C folders. Then open my Urban folder. Go to examples folder. I'm going to open my project sample folder. Here, let me open it right now. I'm going to open the project space. Okay, let me open. Okay. I started my program by the title. The title I name it as. Okay, actually I already put this title. I'm going to change this title. I'm going to change this one as defining data. I have included Urban 32 library, like I have explained before. This allows you to use the library functions from the author. The data segment, data directory, allow us to declare variables. I have these two from previous video, and I have my message as a string is byte. I put my string inside the double quote. I have used the 0DH 0AH. First one give me a line written, and second one going to give me a blank line. I end with a new. I have my second string, my name. I end with a new line. Here, let me show you how to define different data types. Suppose I want variable 1 to be a byte. I can say variable 1 is storage size or data type byte. I'm going to put a variable 10 into it. Variable 2, I use a sign byte. I'm going to put a -100 into it. And then variable 3, I can use like a word. I can use 200. And a variable 4, I can use double word. No, not double word. I want to use a signed word. Okay, there. You have to watch out what's the largest number or smallest number you can put into a word or a sign word. This one, let me just try 1000. I know 1000 goes into a sign word. Next one, I'm going to declare a variable 5, and I'm going to use a double word. I'm going to use let me see what's the size. The size could be okay. It's huge, the size, but I can put a value at 65,000. I think this is safe. And V6, I'm going to use S double word, and I can use positive 2000. Okay. So this is how you declare variables using different storage size, or we say different data type. If you want to print out any of this, you have to use some of the library functions. And we're going to cover library functions in detail in chapter 5. So here, if you don't want to verify any of this, you should be fine. Here I just print 2 strings to the output screen in the main. You don't have to do anything about your declaration of your variables here, but I can try to show you one way to verify your variables. So I can use a move statement. I can move UAX register with, first let me try to use AL. AL is the lowest byte in UAX register. I can use AL to move V1 into it. V1 is a byte, so it can be moved into AL. AL is a 1 byte. So you have to match up these two size bad go to bad. You cannot mismatch the size. That must be the same size. So after you have this, you can call dump register. This is a library function. Dump regs is about dump register's value on your output screen. If I dump registers, I can see UAX with AL to be V1. That means could be 10. Let me try to build my function. It succeeded. I'm going to run. Let me check out. So I have 2 strings print out. That's fine. My AL should be A means 10. Yeah, I have variable 110. I copy into AL, and that's 10. Your output is in hexadecimal format. So 0A is the AL. That means it's 10. So that's fine. To be you wanna clarify the upper half here, you can move 0 into UAX. So let me try to move UAX with initial value 0. So okay, let me clean up UAX before I use AL inside UAX. So build my solution again. I can debug again. Here you see I have cleaned up UAX before I use it. After I clean up UAX to be 0, I move 10 into AL. Last 2 digits in hexadecimal is AL. So I have 10. A means hexadecimal 10. So that's right. Let me show you one more example how to verify your variable's value. Suppose I want to use V3. V3 is a word, so I can move BX. BX is 16 bits is a word, so I can use BX to copy V3 into it. Okay, and then I can. Before I use BX, I can move EBX with value. So I clean up EBX before I use it. I use the 16 bits of EBX, that's BX. So then I can call dump register again. And okay, let me verify by building my solution. Then execute my solution. Okay, so first dump register shows my V1 in AL. That's 10. That's right. My second one, I move second dump register. I move V3 into BX. So first I clean up EBX. So I clean up EBX. My V3 is 200. Okay, so let me see EBX. This should be 200. C is 12. 12 times 16 plus 8, and this gives you 200. That's right. Okay. So if you want to verify more, you can use different registers. Okay, this is the way how do you do it. Thank you for watching this video.